Hey guys, welcome to Algebra 1. Today's topic is going to introduce you to the world of polynomials. Get ready to apply some of what you learned in pre-algebra to help you get through this one. You ready? Let's go. All right, so in order to know exactly what a polynomial is, I kind of have to take you back a little bit to what a monomial is. Because a polynomial is the sum of two or more monomials. But what's a monomial? Well, a monomial can be just a regular number, like 7 or 12 or -4. Or the fancy way to say a negative number in algebra is a constant term, because its value doesn't change. That 7 will constantly be 7. It will never change. That 12 is constantly 12. And that -4 is constantly -4. So a monomial can be a constant term or a regular number. Okay? Monomial can also be a variable, like x or v or y. Those aren't constant terms because their value can change. So we call them variables. So a monomial could be a variable. A monomial could also be the product of a constant and a variable. For example, 5x or 7b squared, -12cd. Those are also monomials. Basically, a monomial in general is one term, either a constant term, a variable, or the product of a constant and a variable. All of those are considered monomials. A binomial is a polynomial that consists of two terms. So for example, 4x plus 1. I've added two terms together. It's called a binomial, is its more specific name. 3b squared minus 1, that's a binomial. X plus 3y, that's a binomial. A binomial is a polynomial that only consists of two terms. It's a lot of tongue twisters on this one. Okay. A trinomial, I bet you might have noticed from that prefix tri, is a polynomial with three terms. So for example, 5x squared plus 2x plus 4. Or, here we go, 4a cubed b squared plus 6b minus 1. That's a trinomial. It's the sum of three terms. Or x cubed minus 8x plus 12. That's a trinomial. A trinomial is a polynomial with three terms. You can kind of think of polynomial as like the name that encompasses the big group. But more specifically, you can have a monomial, which is just one term, a binomial, which is the sum of two terms, or trinomial, which is the sum of three terms. But collectively, we refer to them as polynomials. If you think about it, poly, that prefix, it just means many. Polynomial is the sum of many terms. Okay, so one kind of problem you'll run into in the world that is polynomials is you have to find the degree of the polynomial. Now, how you find the degree of a polynomial is you have to zone in on the exponents. Your largest exponent will be the degree of the polynomial. So the value of that largest exponent is the value of the degree of your polynomial. And we have to take term by term. We've got to go term by term to see what exactly is the degree of each term. Okay, so bear with me for a second. So for example, let's get that pen. All right, so for 5x squared, my exponent in that first term is a 2. So I can say, well, okay, the degree of that first term is 2. All righty. Now for the second term, let's go underneath. 3x squared, y to the 4th. In that term, I have two exponents. So what you do when you have more than one exponent in a term is you just add your exponents together. So here I have a 2 and a 4. So I'd say, all right, well, the degree of this term is 2 plus 4, which is 6, right? All righty. So far, it's looking like the largest degree I've got going is 6. Now look at that -6, that constant term. All right, now we got to throw back to your knowledge of exponents for a bit. You remember that when you're dealing with exponents, for example, I can raise anything to the 0 power and it'll equal 1, right? So I could think about this as -6 times x to the 0 power, because essentially it's the same thing as -6 times 1. So I'm not changing the value of that constant term at all. But knowing that and looking at it this way will help you figure out the degree of that constant term, because now you've introduced an exponent to that term without actually changing its value. So now I can see, well, okay, the exponent's 0. So the degree of that constant term, that -6, is 0. Or a shortcut is that you could think about it like every constant term will always have a degree of 0, because you can treat every single constant term in that same fashion. So for terms where you actually see exponents, just take them. So like for 5x squared, the degree was 2. For that 3x squared y to the 4th, I had to add those exponents together. So the degree was 6. And then for my constant term, that -6, the degree is 0. So now looking at all of your degrees here, you have a 2 right here. You've got the 6, and you have the 0. So out of 2 and 6 and 0, the biggest value is 6. So I'd say, okay, the degree of my polynomial is 6, because it's whatever that largest degree is amongst all your terms. Okay, let's do another one. Make sure you got a hang of that. Okay, so what is the degree of the polynomial? 8x squared z cubed plus 5z squared minus 1. Alrighty, so let's find the degree of each of these terms. Gotta shift that problem up a bit, give myself a little more room. Alrighty, so for my first term, I have 8x squared z cubed. So I have more than one exponent here. I'm going to need to add the exponents together to get the degree of that term. So 2 plus 3, that's 5. So I'd say, all right, well, that first term has a degree of 5. Alrighty. Now let's look at that second term, 5z squared. All right, well, I've only got one exponent there, so that's simple. The degree is 2. Is my only exponent there, is 2. All right, then I see I have this -1 here. So that's a constant term. So you remember the shortcut that we established on that last one? Every single constant term has a degree of 0. And we saw that by looking at how we could represent that product, a constant term times x to the 0 power. So that constant term here, -1, has a degree of 0. So now check out all your degrees. Which one's the biggest? The 5. So let's say, all right, this polynomial has a degree of 5. All right, let's keep going. All right, so what is the degree of the polynomial? -7a cubed b plus 2a cubed plus b squared. Okay, so take each term separately, each monomial separately. All righty, so you have -7a cubed b. Okay, so you remember with exponents, when you don't see one, you have like this term right here, or this part right here, this b, there's a 1 I'm not seeing. So I have a sum of exponents here. 3 plus 1, I'm going to have to deal with that. All right, so 3 plus 1, that's 4. So this monomial has a degree of 4. All righty, now I've got my 2a cubed. So 2a cubed, I only see this one exponent here, so that's simple. This one has a degree of 3. All righty. Then that last monomial, b squared, there's just one exponent in this one. So the degree is 2. Then check out all your degrees. You've got 4, you've got 3, you've got 2. The biggest one is 4. So the degree of this polynomial is 4. All right, let's keep going. And I do believe it is your turn. So go ahead, press pause for a little bit, work your way through this problem, and when you're ready to compare answers with me, go ahead and press play. All right, ready to check? Let's see. Let's get the pointer. Just gonna move that out of the way. All righty. 9x to the 5th y minus 4x cubed plus x squared. What's the degree? It is 6. Okay? If you need to see how I got that, this is how I got it. Let's get the pen. Okay, so I took each term individually. So 9x to the 5th y. So I didn't see an exponent with that y. So that told me there was a 1 that I wasn't really seeing. Then I had more than one exponent, so I need to add them together. So 5 plus 1, that's 6. So I knew that first term had a degree of 6. Then I took my next term, negative 4x cubed. I only had one exponent to focus on there, the 3. So this term has a degree of 3. Then I had the last term, that x squared. Only one exponent to focus on, and it's a 2. So your degree of that term is 2. Then check out all your degrees, which one's the biggest, in this case the 6. So the degree of the polynomial was 6. And that's how I got that one. Okay? Let's keep going. A little more to introduce you to polynomials. All right, you may also run into problems that ask you to find the leading coefficient. So how you do that is you first have to make sure that your polynomial is written in standard form. Standard form means that your polynomial goes from the term with the largest exponent down to the term with the smallest exponent. That's how you write it in standard form. Now, sometimes the polynomial will already be given to you in standard form, so you won't have to worry about it, and then you could just pick out your leading coefficient. But sometimes it's not given to you in standard form. You've got to do a little maneuvering to get it there. Okay? So taking a look at this polynomial, I see it's not written in standard form because my largest exponent is a 3, and that 7x squared is not written first. So I need to rearrange this. Alrighty? So I'm going to write this as 7x cubed, because I'm going to take that first term first. Now you notice how I'm circling the plus sign in front of it? That's just to let me know what the sign of my term is. So I know that this 7x cubed is a positive 7x cubed. And it's going to have to be written out front here if I need to write it in standard form, because it has the largest exponent. Alrighty, so 7x cubed, and I've handled it, so I'm going to kind of cross it out. Then going down the line, I've got an exponent of 3. I see I have an exponent of 2, this 8x squared. And there's no sign out front, so you know from pre-algebra that means it's positive. Okay, so I can write this as 7x cubed plus 8x squared. Alrighty, and I've handled that. Okay, I've got an exponent of 3, exponent of 2, and you have an exponent of 1. Do you remember that negative 2x? There's a 1 there that you're not seeing. I'm going to circle that term. Alrighty. So you notice I circled that subtraction out front. That subtraction tells me that 2x is negative. So when I'm rewriting my polynomial, I'm going to write minus 2x. Minus 2x, negative 2x, they're kind of interchangeable. You can think about them the same way. Alrighty. I've handled that. Now I see I have this constant term out at the end, this negative 4. So at the end here, minus 4. So now this polynomial is written as standard form. The exponents go from 3, 2, 1, and then a 0. As you remember, I can think about that negative 4 as negative 4x to the 0. Alrighty. Now they don't always go sequential like this, like down the line, like an exponent of 3, an exponent of 2, an exponent of 1. Sometimes they skip 1. But you just want to make sure that those exponents go in descending order. Alrighty? So now that this is written in standard form, now I can figure out what the leading coefficient is. The leading coefficient is the coefficient of your first term. So it's the leading term is coefficient. My first term is 7x cubed, and the coefficient there is 7. So the leading coefficient of this polynomial is 7. And you're all done. So it's like a little bit of work to get there, but the answer is just that constant. That's 7. All right, let's keep going. Now, what's the leading coefficient of this polynomial? So I see I have 3x minus x to the 4th plus 5x squared. Okay, So I'm going to have to do some maneuvering because this is not in standard form. And I know that because I see that that middle term has the largest exponent, has an exponent of 4, and it's not written first. And when polynomials are written in standard form, the exponents start from the largest and then go down the line. So I need to do some rearranging. That negative x to the 4th needs to be written first. So negative x to the 4th. All right, handled that. I don't have an exponent of 3, but I do have an exponent of 2. And it's attached to this term right here. So that's a positive 5x squared. So plus 5x squared. Handled that. And then my last term is this 3x. And there's no sign out front of it, so that tells me it's positive. So I can write that as plus 3x. Now that this polynomial is written in standard form, now you can pick out the leading coefficient. Your first term is negative x to the 4th. And same for coefficients as exponents. When you don't see a coefficient, there is an invisible 1 there. So this first term is like negative 1x to the 4th, which would mean that its coefficient is negative 1. So my leading coefficient for this polynomial is negative 1. Okay? All right, let's try one more. 2 plus 9x. All right, that's not in standard form. How do I know that? Because that x has an exponent of 1. I know that this 2 is a constant term, so I know there's like an x to the 0 there. So this isn't written in the right order. This term should be first because it has the largest exponent. So 9x, it's positive, but you don't have to write the plus when it's the first term. And then you see you have handled that. And then you see you have the 2. And when you don't see a sign out front, that means it's positive. So this really should be written as 9x plus 2 for it to be in standard form. So now that it's in standard form, just look at your leading coefficient, or look at your leading term. It's 9x, and the coefficient of that first term is 9. So the leading coefficient of that polynomial is 9. All right? All right, it's your turn. Go ahead and press pause, take a minute, and work your way through these problems. Remember how we did it. First, you need to make sure that polynomial is written in standard form. Then you can go ahead and pick out the leading coefficient. Right, when you're ready to compare answers with me, go ahead and press play. All right, you ready to check? Let's check. Let's get the pointer tool. Okay, for that first polynomial, 3 plus 4x minus 9x cubed plus 17x squared, the leading coefficient, negative 9. And for the second one, 11 minus 3x squared plus x to the 4th, that leading coefficient is 1. Okay, if you need to see how I did it, here we go. All right, so first I noticed this wasn't written in standard form because the term with the largest exponent wasn't written first. So I spotted that 3, and I knew it was a part of that term, so that should have been written first. Negative 9x cubed. All right, then I handled that. I saw I had an exponent of 2, and that's the next one going in descending order. So that's a positive 17x squared. So plus 17x squared. Now I handled that. Now I see the 4x, it's positive. So plus 4x. All righty. Then I see the 3. There's no sign in front of it. Let's cross it out so I dealt with it. There's no sign in front of it, so it's positive. So plus 3. Now that it's written in standard form, look at your first coefficient, or look at your first term. It's negative 9x cubed, and the coefficient of that term is negative 9. So the leading coefficient is negative 9. Okay? Need to see the second one? Alrighty. 11 minus 3x squared plus x to the 4th. This wasn't written in standard form, so I had to rearrange it first. That 4 is the largest exponent. So that means that x to the 4th should be written first. It's positive. So x to the 4th, right? I've handled that. Next exponent going in descending order would be 2, and it's attached to that term. So minus 3x squared. Okay, now I've handled that. And that constant term, 11, there's no sign out in front of it, so I know it's positive. So plus 11, right? So then I gave it a glance over. I see that my first term is x to the fourth. I don't see a coefficient, so I know there's an invisible 1. So my leading coefficient is 1. All right. Okay, I hope you're getting comfortable with the world of polynomials. There's a lot more that we'll do with this topic, but I hope that you felt like you got a good introduction. I hope I see you back here soon. Bye.